Hello everyone, and welcome to Mobycon's next webinar, The Principles of Traffic Calming. In a few moments, you will start hearing from our consultants, Leonard Naut and Mary Elbeck, transatlantic call. So we've got Leonard here in studio with us and Mary calling from Durham, North Carolina. So welcome again. Just like the last webinars that we've been running, we will be using Menti tonight. So make sure that you're logged on and you'll see the code shortly. If you have any questions, please make sure to enter them through Menti as well, and we will address them at the end of the presentation. But before we get started, we are going to ask a couple questions through Menti, so make sure you're logged in now. So the first question is, what profession do you identify with most? And so if you can give us a sense of where you're coming from, what your background is, that will help us in terms of making sure we're answering the right questions in the right way as we get forward with the presentation. I'll give a couple minutes for that. There's always a little delay between YouTube and us live in the studio. So we are seeing some results, just not on our screen, which is fine. We can figure that out. But we're seeing we've got some traffic engineers, some planners, some advocates, and some urban designers. So a pretty good cross-section. Unfortunately, you can't see it. But we'll go to the next question. We'd like to know whether or not you've been to the Netherlands before. And so we've got yes, no, or not yet, hopefully waiting for flights to open up again. We're getting some results. Again, we'll figure out the Menti on your screen as we go through, hopefully. But in the meantime, lots of you have been here, which is great, which means you've experienced the infrastructure that Mary and Leonard are going to talk about today. Not many haven't been here yet, but a few would like, well, a few of you haven't been and would still like to come. Okay, so we know we're not, you've got some experience of what you're about to hear. Okay, so I'm going to pass it on over to Leonard now to give you a brief intro and enjoy the webinar.
Thanks, Melissa, and welcome everybody to this webinar on traffic calming. Today we're going to talk about traffic calming, all the ins and outs at a network level and a street level. But I always like to start this presentation with a little anecdote. On the PowerPoint you'll be able to see in 2 seconds. There we go. This is a street close to my mother's house. It is a rural road along the canal near Delft. And this was a road that was very busy. It's quite narrow, not quite suitable for the amount of traffic it was taking, because every time the adjacent motorway was backed up or was heavy traffic, people would use this as a bypass. So it was a lot of through traffic, people speeding along this narrow road with not quite appropriate bicycle facilities. So you can imagine that the residents of this road were really fed up. It was very unsafe. And the city tried to figure out what to do, and there was not a lot of options. Like expanding the dike would be very expensive. Putting in a parallel route was not quite what they wanted to do. So they decided that some traffic calming was in place. They studied on a few options, and this came out to be the best option. What you see is a movable bollard. So every time the bollard goes up, nobody can pass through, and then you have to wait till the bollard drops down, and one car can go through at a time. Now you can imagine that this is quite a strange context for a traffic calming treatment like this, but it is highly, highly efficient. Because this bollard, in rush hour, it would only drop once every 35 seconds. Now you can imagine day one, traffic backs up on the motorway, people expect to take their normal shortcut route along this dike, and they end up waiting for this traffic light for 35 seconds for one car to pass. Day one, traffic was horrific, about an hour and a half delay just on these 2-3 kilometers of roadway. Second day, almost no delay. Third day, traffic was gone. What I want to try to say with this story is that traffic calming, although often is conceived or perceived as quite complicated, it usually just takes some political willpower and a little bit of engineering. Overall, this is not a very difficult question to solve as long as you have the guts to do it and know the goals that you try to achieve. That's just a little bit of context of hardcore traffic calming in the Netherlands, how it can be done. But throughout this presentation, we'll give you a little bit more context about where it comes from and about some strategies and some tools that you can use to retrofit these kind of treatments to your environment. So with that, I'd like to pass it over to Mary, who is calling in from Durham, North Carolina, and I hope we can see her now on the screen. You don't know how complicated a transatlantic webinar is. There's a lot of tech involved. Mary, can you hear us?
Yes, I can hear you. Thanks, Leonard.
We can hear you.
Can you all hear me okay?
Yes.
Okay, great. So when we consider the principles of traffic calming, it's easy to conceptualize them at sort of two different levels, the network level or the systems level and the street level. Are we on the slide by any chance that says principles of traffic calming at the top? Okay, perfect. Since we like to say that traffic calming starts at the network level, I'll be doing the first half of the webinar kicking off with that. First looking at the influence of sustainable safety on the Dutch approach to traffic calming. And just a quick sort of note there, for the purposes of this presentation, we'll be using sustainable safety, safe systems, and Vision Zero interchangeably. And then next we'll look at when to separate and when to mix related to the functionality of roads. And then last but not least in this first half, we will look at how to use traffic psychology to make road users behave the way you want them to behave. And then Leonard will take us through the street level approaches to traffic calming. So as many of you know, the Dutch have not always had nicely calmed streets. On our next slide here, you can see that they faced a similar rise in car culture that the States, as well as many other countries, did up into the early 70s. And we can really see a parallel there in this graph of traffic fatalities. It peaks in 1973. And this coincides with both more traffic fatalities than the public was willing to accept, including over 300 children. So this public pressure, not to mention the oil crisis, was the push that the Dutch government needed to sort of take a more proactive approach to addressing the problem. And as we can see in the chart, the decline in those fatalities is quite obvious. So in the 1980s, this decline starts to taper off a bit, and the government realized that a little bit more needed to be done. So this is where they start to research and implement what we essentially know as sustainable safety today. So on our next slide here, we see that sustainable safety starts with the idea that all traffic fatalities are unethical and therefore preventable. And so as planners, designers, engineers, it's our responsibility to reduce the number and severity of them. So sustainable safety plays out in a number of ways, of course, but when it comes to infrastructure, one of the most lasting outcomes has been the expansion of 30-kilometer-an-hour zones. And that's very related to the establishment of this sort of functional categorization of roads. So there's 3 different categories with associated speeds, which we'll sort of get into later, but that establishment of 30-kilometer-an-hour zones is due in large part to the research behind this familiar chart on the next slide. So what we're seeing in this figure, I'm sure a lot of you are familiar with it. This is the influence of impact speed on the probability of death, with our solid line being the most likely estimate, and then our dotted lines showing those 95% confidence limits. So basically what our sort of takeaway from this chart is that at speeds lower than 30 kilometers an hour here, there is a 10% risk of fatality in a crash. And then above this speed, the risk of fatality there increases exponentially. So what this translates to in terms of sort of safe, forgiving infrastructure is that categorization of roadways we refer to that looks like this on our next slide here, where we see this slide with the heading separating and mixing. So in our columns, we have 3 main roadway functions or categories. The first being access or local roads, the second being distributor or connector roads, and the third being our through roads. So the look of this varies a bit from your rural to your urban context, but generally there's a pretty clear design prescription and speed limit prescription for each of those categories. So a quick note on the speed limits, or two quick notes actually. The first is that in the Netherlands, they're quite lucky in that their design and operating speeds tend to match the posted speed limit signs. So when we refer to speeds, it's everything from posted to how fast people are actually driving on the roads. And then my second note here is that while these graphics look like US speed limit signs, we do have an international audience with us today, so the numbers are all in kilometers per hour. Hopefully this is obvious. I haven't, by looking at the 120 mile per hour speed limit sign, thankfully I haven't actually seen any of those in miles per hour. So all the numbers that we're using throughout this presentation are metric. So it's easy to think of traffic calming in measures of speed, but we also know that traffic volume is also a key ingredient in terms of how calm, how safe, how comfortable a roadway feels, particularly from the perspective of someone walking or cycling. So on our next slide here is a chart of when to mix and when to separate. So again, generally the rule being to mix at speeds lower than 30 kilometers an hour. Again, related to that graph, you can see our graph in the top right, and about 2,500 cars per day or average daily traffic. And then above that, you want to start separating modes out with degrees varying based on speed as well as traffic volume. So once you hit 50 kilometers an hour or about 4,000 cars per day, that's where you really need to fully separate your cyclists and definitely your pedestrians. There's two other factors to consider in knowing when to mix and when to separate, including the width and the weight of vehicles, but I think we'll share that presentation for another webinar. So going to our next slide, so we look again at our overview of roadway categories, this time with the bicycle facility also included in that categorization. What I think is interesting to note is the lack of painted bike lanes in these categories. I have pushed many times for an explanation as to when it's okay for your sort of regular painted, your regular striped bike lanes, sort of when would that be appropriate? As an American, that tends to still be the default facility that we see here, as well as across other countries. The best response that I've gotten to that is that painted bike lanes are okay, but not ideal on low volume streets, sort of in that 40 kilometer an hour range. So it's really a pretty small window where a regular painted bike lane would make sense. Rather the preferred option would be to calm traffic more or further separate your modes into that more sort of distinct travel lane, separated bike lane and sidewalk. And that sort of plays into the intuitive design approach that Leonard's going to talk to us about later. So on our next slide, we're going to be focusing more on the built-up area today, even more specifically on 30 kilometer an hour zones. And this is where I think it gets really interesting. The Netherlands has a modal share of about 27% for bikes across the country. In some areas, this number increases to 60%. So we all know people obviously feel safe enough to ride, it's comfortable, it's easy, et cetera, all the things that make the Netherlands wonderful. But what I found surprising is how much of their road network actually features dedicated bike facilities. And the answer to that is that it's only 20%. And the reason for that is that the majority of their streets fall into that 30 kilometer zone of calm traffic. So again, 80% of roads have people driving slower than 30 kilometers an hour. And my next question after sort of letting that settle was, how do they get away with that? So they get away with that with a little bit of traffic psychology. So on our next slide here, we see traffic psychology for calm networks. This is a chart called the Staircase of Mundermann, named after Hans Mundermann, the father of shared. Hopefully, we want you to remember everything from this presentation, but if not, we really want this sort of concept, this slide, to be one of your major takeaways. So on the left-hand side, on our y-axis, we have divisions by road type. We see our 3 roadway categorizations again. And then on the bottom, we have our duration of travel. And so basically what Mundermann found was that at 30 kilometers an hour in an urban setting or 60 kilometers in a rural setting, people are willing to drive this slowly for upwards of 6 minutes. Then after that, we need to provide them with a faster route, or they're going to start sort of pushing the speed limit there a little bit. So then on a distribution road in the built-up area, people would be willing to drive at 50 kilometers for up to 9 minutes. And then after that, we should really provide them with access to a highway. So this perception of time is quite similar for people on bikes as well. In a primary network for cyclists, this translates to providing a mesh width or a priority route in the network approximately every sort of 500 to 700 meters. So when we apply this traffic psychology to the street network on our next slide here, again, we see that our roads are categorized into a hierarchy of through roads, distributor roads, access roads, and each one of these is accessible within those timeframes laid out in Mundermann's staircase. So for example, if you're a driver starting out in this sort of quadrant of access roads, you should be able to reach a distributor road within 6 minutes from pretty much anywhere. And what this does is it allows for these sort of larger traffic calmed islands, and therefore eliminates that need for lots of heavy separated infrastructure. So despite the majority of streets being traffic calmed, people can still move efficiently. They can still get to their destination quite quickly. And let's see, on our next slide here, we are jumping down to Gouda, or Gouda, in the Netherlands, where they do in fact have a large cheese market. So we're going to look at how a mobility network was created for Gouda. And one of the first things they did was to really think critically about the way that their city functions. Who actually needs access to this space? For what purpose? And then from there, the functions of those necessary roads will sort of start to fall into place. So looking at this picture, we can imagine a high demand on public space and a need for quite calmed roads surrounding that area. So on our next slide, we should see a map of the pedestrian areas in Gouda. So we're looking at all of our what we call people places. So these are the areas where people are walking or gathering, where that should really be the priority. So that red area in the very center is pedestrian only, and then that is surrounded by a 30 kilometer an hour maximum speed sort of city center bubble. And then similarly, we see low speeds in the surrounding green residential areas. And then on our next slide, we start to build out the bicycle network. So starting with our blue routes, this is our primary network for people cycling. This is where cyclists have priority, either through a dedicated bicycle street or nice separated cycle track. Then we see our green routes. These are our supporting routes, sort of mixed traffic, shared street type atmosphere. And then in red, we have our regional connectors. So if we think back to our Staircase of Mundermann and thinking about how we determine this mesh width, the distance between these primary networks, there should be a priority route accessible for cyclists, those blue lines, within sort of every 6 minutes or so. And then on our next slide, we'll look at the car network. And here you can see that the primary car network is really quite limited. It also sort of parallels the primary bike network, So in the downtown area, they're green. They're sort of faster 50-kilometer routes, quite similar to the bike routes. And cars are also allowed in most areas within the sort of the otherwise shaded gray streets. This is as local traffic, but again, it's quite traffic calmed. No through traffic is allowed. Cyclists and pedestrians are really determining the speed on the streets there. And so on our next slide, we'll just do a quick overlay of the pedestrian and car network to get a better sense of those traffic calmed areas sort of within the scope of the car network. So all of the green shaded areas are 30 kilometers or slower, but again, then cars have access to their green car network within 6 minutes. So we keep our motorists driving happy, slow, and we keep our pedestrians feeling safe and comfortable. So then we're going to leave Hauta and head north to Groningen. So I want to talk in our next slide about just sort of one more little bit of philosophy, I guess, related to our approach to traffic calming. And that is that we believe that every street tells a story. Hopefully it's a well-told story, and that it's designed to reflect what's going on around it. So one example would be a highway or a through road. It's really easy to picture a landscape around us that doesn't offer much reason to stop. You know, there's plenty of sort of free-flowing lanes of traffic to keep us moving. Now let's picture a downtown or local access street. We've got shops and restaurants, basically areas that should largely feature people on foot or at least moving slowly if they're biking or driving. But what we see a lot of times outside the Netherlands is that the design of the road doesn't actually change that much as we hit that sort of downtown area. You know, it remains a sort of 4, 5, sometimes even 6 lane highway feel going through a downtown. So you have shops and restaurants that are telling people to move slowly. And then you have the road telling people to move quickly. There's nothing to see here. So there's sort of a mismatch in those stories that they're telling. So on our next slide, where it should say before at the top, this is the same picture. There's no differences you're supposed to see between the two. As a non-Dutch person, I find it really difficult to believe that this is the before photo, but when we take a closer look, we do start to see that there's sort of a mismatch between the street's function and the network and its surrounding activities. So the street is designed to behave more like a distributor road with separated bicycle and pedestrian facilities that are sort of encouraging this forward movement and flow. Our driving speeds here are probably closer to 50 kilometers an hour than 30 kilometers. But at the surrounding activities on this street, we have businesses, we have shops, we have restaurants. They're very much typical of what you would want your sort of local access street to look like. So the city, they decided the activity surrounding the street didn't match the story the road was telling, and so they redid it and presenting us with this after photo. So now we have much more of a sort of traffic calmed environment. There's still some separation, but it's clear that pedestrians have more room. They have the priority at crossings, and the speed here of drivers has probably dropped closer to that 30 kilometer an hour max. You know, they could probably layer on a few more placemaking elements, but from an infrastructure side of things, they're good. So now these stories are in agreement. It's an area that's for people walking. It's a destination for people cycling. Overall, the city has created a more intuitive space by having the street and the surrounding area tell the same story. And with intuitive spaces, we're going to see better behavior, and well-behaved road users are certainly something that we're looking for when we think about traffic calming. So now I'm going to hand it back over to Leonard, and he is going to take us through these sort of street level elements now that sort of motivate those slower speeds even further.
We keep talking about the network being so important even when we talk about traffic calming, and that is just because if you don't sort out your network properly, you're never going to get the speeds that you want. That Staircase of Mundermann, while it's just an example of the way we think about things, is so crucial in getting people to drive, the way you want them to drive. But in this next section of the presentation, I'll talk you through a few of the design elements and of the interventions you can do at the street level to make sure that drivers mostly behave. So we're going to talk about, I've got 4 lessons. I tried to keep it short, but we might go over a little bit. 4 lessons, mostly about width, about design, what kind of materials to use, and a little bit about intersections, but not too much because we cover that in a whole range of other master classes. But before we start, I'm interested to see how many people live in cities where the city is actively investing in traffic calming. With actively, I mean they're going in to retrofit existing neighborhoods to make sure that the speed in those neighborhoods is more appropriate for the environment that it is. So we have another little Mentimeter question, which again doesn't show up on your screen probably, but it does show up on mine. I've got a second screen. You don't know how many screens there are here. We have about a third saying yes, my city is investing actively. A lot of cities are working on it, which sounds like they're doing a lot of studies, but not quite getting it done yet, which may be an indication that they're finding it hard to know how, which is good. Good that you're on this webinar. But also about just under a third or a quarter of responses say no, they're not working on it, which is bad. Because every city should be working on it. It's a huge challenge to retrofit your streets, but I'll give you a few tips on how to get it done even in a retrofit situation. So, first lesson, enforcement is futile. That sounds harsh, but I like to be a little bit harsh. Putting up a sign, putting up a speed camera, asking for the police to do speed checks on your 30 km/h street is not going to cut it. I will go a little bit further. Dutch streets that are 30 kilometers or less are not policed. The police is of the opinion that if you have speeding on a local street, the design is bad and the city should fix that. It's not their problem to fix because they know enforcement's not going to cut it. This is a scene from the US where they do think enforcement, well, some cities, I'm not going to blame all of the US, some cities do think enforcement and more signage will solve the problem, and then you get these kinds of atrocities where you just keep putting up reflective signs to try and get people to slow down, put up speed cameras, but all it does is anger drivers because they have to remain driving slowly when it doesn't feel right. The design of the street clearly doesn't match its purpose. So what you need to do is put hard interventions in. Put some stuff on the street that really makes people want to slow down. These are a few of the tools in the palette, including diagonal diverters, which are great, where you divert the traffic to only be able to turn left or right. Little mini roundabouts, which are very popular in Vancouver, for example. Curb extensions, which we'll cover a little bit further in the next few slides, but also on the bottom right, the modal filter is very important and very popular at the moment because of COVID-19 open streets programs, which is great to see because people will experience their local roads in a very different way because of it. So sometimes you just have to put a lot of stuff on the street to get people to slow down. And sometimes you go this far where there's really no purpose for people to drive down the street anymore, and you create this kind of open street where the street is no longer a street, but it's a public space. It's an extension of people's houses where people can park their bikes, sit outside, and enjoy the neighborhood with their neighbors, which is very, that's the goal you want to work towards in some streets, not all streets. Also, this kind of design where you flip the parking from left to right, keep the street very narrow. This really forces people to slow down. It's just a sign in a straight road wouldn't be enough, but you have to have the physical attributes that make people think about how they drive and where they drive and how fast they drive. It's physically impossible to drive very fast on a street like this. So that's a key lesson, design for the behavior that you want. And then probably the most important lesson, width is everything. A wide road will never be properly traffic calmed. You just need to get those widths down. Some cities in the US are working on 10-foot lanes. I still even think that's too wide. You need to make the lane properly wide, and I'll give you a few examples. This is an example from Haarlem, which is extraordinary even for Dutch principles. You can see the sign on the left that says no wider than 2 meters, 2.0 meters. That's about the width of a wide car. But a larger truck is banned, not allowed on this street. And you can see cars, when they turn into this street, they're going very, very, very slowly. Not because the sign tells them to, but because they're scared to scratch their cars. If drivers are scared of one thing, it's to scratch or damage their own vehicles. So if you make it narrow enough, it'll work. Another nice example, that kind of making the street narrower or reducing the width doesn't have to be very expensive. It can be as simple as putting a rock on the road, either intentional or unintentional. Here's a nice example from the city of Utrecht, where they put two poles next to a bridge. They don't want heavy vehicles on this bridge because the bridge is not that strong. And now they've put two bollards, about 2 meters, 2.1 meters apart. So you can see very wide cars will really struggle to get through, which is fine, because as soon as they think they can't pass, the first thing they do is they slow down, which is exactly what you want at these dangerous intersection points. Some cities get the message, width is important, but they have very, very, very wide roads, and they don't know what to do with it, so they think paint will solve it. It helps, but it's not enough. There's an example from New York where they went down from probably 3 lanes to 1, which is fantastic. They still kept the parking, which is fine. But now you've got these huge wide buffers. By putting the cars in the middle, nobody's really going to feel the need to slow down. If you want, nothing is physically stopping you from driving 100 kilometers an hour down this road. So paint is a good start, but it's never enough to really have enduring change. Now, is it all bad in North America? No, it's not. This is a photo from Canmore in Alberta. Alberta is the Texas of Canada, as they say. Very large cars, pickup trucks are very common here. And they designed one of their 30-kilometer-an-hour streets, more in the Dutch way, red bike lanes separated with big fat bollards. But the width of the carriageway is only 5.4 meters for bidirectional car traffic. So that equates to about 16 feet. Checking with Mary. It's pretty narrow. But it works perfectly well. They took out the center line marking just to give it a little bit of ambiguity. 2 cars can pass, but they can only pass very, very, very slowly and very carefully. And what you see is that the operating speed on this street is about 26, 27 kilometers per hour, which is fantastic, even in asphalt, like you don't need bricks. Then the third one, an excuse. We can't reduce the speed because the volume is too high. Speed and volume are two very different things, and if you have a high volume, that doesn't mean that you cannot reduce the speed. You just have to be smart about your interventions. We have a few examples in a system that we call driving slower goes quicker. It is a comprehensive street design methodology for high volume, low speed streets. This is one example from here in Delft. This carries about 10,000 motor vehicles a day, so it's a reasonably high traffic volume, even for Dutch standards. You can see they put a little raised center marking in instead of paint, which makes people want to drive within that asphalt lane, so they stick to their lane, and that lane is actually surprisingly narrow. They do obviously have separated bike lanes because the speed limit is 50 kilometers per hour, even though the design speed is only 40. So the operating speed will also be closer to 40 than to 50, which means a high volume but traffic calm street. And then this is the cross-section for that street that I just showed you. You can see the driving lane is actually 2.66 meters wide, so it will fit a truck. But because of the middle section, which is 65 mils wide, a bit of a buffer between the cars, so they can operate safely. A fire truck can still race through if they need to, but for normal traffic, they'll feel a little bit crammed in that narrow driving lane, and thus the first thing they do is they slow down. Another example, even more vehicles a day, 12,000 motor vehicles a day on this street, which is in Voorschoten, which I won't test you on. 2 separated lanes with a wide grassy median, continuous flow. There is a traffic light here for the zebra crossing, but otherwise you'll see very few traffic lights on a street like this. So it's optimized for flow, but because the lanes are so narrow, this is 2.9 between the curbs, right? So that's a hard vertical edge on either side. 2.9 meters, there's still a continuous and high traffic flow, but at a reasonably low speed. Then at the intersections, because they're often the thing that limits the through flow or the throughput of a road, this is the kind of treatment you can see here in a more suburban context. A very busy, the east-west connection, very busy, about 12 to 14,000 a day. And this type of intersection, the kidney bean intersection, sometimes called, we haven't quite figured out the uniform English name for it yet. But this allows for a high throughput with a big left turn bay where cars can wait to turn left while the rest of the traffic can still continue. The downside is that you do, pedestrians and bicycles do yield to these kinds of, on these kinds of roads, otherwise they won't get the car capacity. So this is a road where if you do prioritize car capacity but want to remain or keep the speed low, this is the kind of treatment you can look for. Doesn't only work in rural or in urban conditions, it also works in rural settings. This is a road in the north of the Netherlands where they have also applied, retrofitted a slightly raised median, which allows for overtaking, but it discourages it. And because of the physical narrowing of the road, you'll see that cars drive a lot slower than in other roads, even though the speed limit might be 80, but the operating speed will be closer to 60. So that the same principles apply, but at a different scale. And then the fourth principle or lesson for today, the devil is in the details. Design details are very important, especially when you're designing for cycling. And the things you want to design for a car to slow down the car may also slow down or make it less comfortable for the bike. So for example, most of the 30 km/h streets, residential streets in the Netherlands, will be outfitted in cobblestones or brick pavers. May or may not look like this. So a pretty wide street with sort of advisory bike lanes, maybe not ideal, but it kind of works in this setting. But if you look a little bit closer, you can see that the pavers are not actually laid in the same way. So a close-up of a similar street like this. On the left-hand side is where the drivers go, with the pavers in a zigzag formation, and on the right-hand side is where the bikes go, where the pavers are stacked very close to each other. Different type of pavers as well. It gets a little bit technical, but it means a much smoother ride for the bikes on the right and a much more noticeably bumpier ride on the left, which gives a straight message to drivers that they have to slow down because they're in a brick street. It just gets a little bit uncomfortable for them. Then we often have this discussion about traffic calming and advisory bike lanes, if it works, if it would work in a US context or in a context where you don't have that many bicycles. This is an example from Utrecht that's often used, where the 20% or 30% of the car traffic evaporated once they lowered the speed limit to 30 km/h. And they introduced this treatment where there was a black asphalt tarmac before. They introduced this, speed went down, car volume went down, bicycle volume jumped by about 20%, even in Utrecht, which already has very high levels of cycling. Sounds fantastic, but what we often see is that treatments like this get mistranslated and used in a US context, and then, oh, that slide wasn't supposed to be there. Oh, where did there we go, that slide. This is an application, an early test of advisory bike lanes in the US, where they get the principles, but there's a lot of design detail that's missing. So there's no red coloring, the street is very, very wide. I think this is not a great outcome from a traffic calming perspective, nor from a safety perspective. So it doesn't deliver the same benefits that you get if you don't take care of all the design details. So the 4 lessons: enforcement is futile. Don't rely on traffic signs or speed cameras to maintain a lower speed. Width is everything. Make sure that your car lanes are as narrow as you can get them. I know there'll be a lot of pushback from safety advocates, maybe even from emergency services, but it is extremely important to get the width to as little as you can. Car volume might be an excuse, but it's not a barrier. You can design high volume, low speed streets as well. And the devil is in the details, so make sure that the level of construction is high enough, the level of detail and the design is appropriate for the outcomes that you want, to make sure that it's still comfortable for people cycling. Now, I can hear you think, yes, okay, but this is all going to be very expensive to retrofit our entire street network. and we just don't have the money for that. This all sounds like expensive stuff. If you look at these pictures, they have red asphalt, red bricks, all these things that we don't have, and that's true. But I think there's 3 key things that you can use in any retrofit situation for quite a low cost to make sure that your current streets, which may be wide, I know still a lot of subdivisions get built with very, very wide streets. You can retrofit those to fit a lower speed limit with these 3 tools. One of them, the diagonal, or like a chicane almost, as soon as the speed limit changes, you often will see a chicane like this in the Netherlands. If you come from a rural environment into a smaller town, there'll be a chicane at the entry. The important thing here is that the offset is big enough. So you need to have like a full lane offset, about 3.5 meters offset, to make sure that people cannot speed around it. And this one has truck aprons as well. So a big truck can still swing around over that little brick area, but a car will try and stick to the asphalt. So center eyelets are a great tool to limit the speed at the transition point. Then the second one, the raised median, slightly raised. It's only like a centimeter or 2, maybe 3. That's something you can apply within an existing fairly wide street. So the width of that raised median can vary from 20, 30 centimeters all the way to 1 meter or 1.5 meters if you want. But retrofitting bricks onto an asphalt street is a very effective way to reduce the speed, because the width will feel much narrower than it was before. And then the last one, we talked about it a little bit, modal filters. Very cheap, very, very efficient. And you can make people feel how big the change is in their street just by putting in a bollard or 2. They can be bollards, they can be planter boxes, they can be giant rocks, they can be whatever you want to be, as long as it physically stops people from driving into that street. We see this a lot with the COVID response. If you want to open street, put a bollard in, and that's highly encouraged, because it changes the network instantly without needing a lot of infrastructure. So that was it from us. I hope we have some questions from the audience. You can still ask questions in the Mentimeter if you want. So far we have, why can you not see it here? That's kind of odd, isn't it? Let me click on it. Oh, no, I shouldn't click on it. Can I go to the screen? No, strange. Well, we have a question. Mary, do you want to do questions? She cannot hear me. Yes.
Yeah, is it
yes,
question
it's question time?
Yeah, let's do some questions.
The first question is, in your opinion, what is the cheapest, easiest to implement and most effective piece of traffic calming infrastructure that a city can install quickly? Wow. I have my answer. What is yours?
Oh, I want to hear yours. The only thing I can think of, or the first thing that is just filling my mind, is that gigantic rock on the slide that you showed.
Yes.
So I'll keep thinking, but what's yours?
I was going to say a gigantic rock. Most places have gigantic rocks somewhere. Just get one, put one on a truck, and plonk it into a street. As long as you tell the emergency services where you put it, I think you'll be fine. And most residential streets will be able to cope. As long as you can maintain access to a specific street, people will be adjusting their behavior pretty quickly. Yeah, big rocks. Maybe we should start a big rock trade. You can ship them to your house. Second question, very little car parking in any of the photos. Where are the cars? We spent a lot of money in the Netherlands hiding cars underground or behind houses. A lot of the bigger streets that I showed you don't actually show a lot of cars, because the function of that road is flow. So we will reduce the number of on-street car parking on those streets, and then we'll add more car parking at the back, underneath or tucked away under a canal if you want. But we spend a lot of money on hiding cars, which is not necessarily something I think is a good idea. Oh, I lost Mary in my ear. But we do have very high parking, minimum parking requirements in most cities. That was a very Dutch question. Let's see if we can find a Mary question. Here in Ottawa, we are a winter city that needs snow clearing and removal. This leads to challenges with narrowing the streets. Mary, do you have thoughts on snow clearing? Or shall I take this one as well?
Leonard, I'll let you take the snow clearing. That's fortunately we don't have to worry about that too much.
Not too much in Durham, North Carolina. Canmore, Alberta has a lot of snow. They did it. They did it by adding a little bit of buffer space between the car lane and the separated bike lane. They also made the bike lane and the footpath at the same level. So in case a little bit of snow from the snowplow plops onto the bike lane, it's not necessarily a huge problem. Because heavy snowfall often is accompanied by lower cycling demand. So that kind of balances out. And otherwise, snow clearing is also often a matter of budgeting, because there's ways to remove the snow without having to plow it onto the footpath. So there's definitely ways around this. Or make the median bigger and put all the snow in the median of the street, obviously. This one's for you, Mary. A total 30 km/h limit, is it a good decision if you don't have any other measures? Your entire city, your whole network, if you make that 30 kilometers.
Oh, to have 30 kilometers throughout the city? You know, I would say it. If you don't have any other measures in place, then just posting the speed limit of 30K is probably not going to get you there. So it would need to be in combination with with other measures.
Yeah, totally agree. It can't hurt, but it's not going to get you a lot of benefits probably, especially on the short term.
There was a similar question on the YouTube channel, I think, referring to the pedestrian zone, maybe, and how to asking if there are lower limits than 30 kilometers an hour. And I do want to address that in those pedestrian only areas or pedestrian and cycling areas, that limit is, or the speed of traffic is slower. It's more determined by pedestrians. They have priority. So yeah, people are driving much more slowly. I sort of think of it as parking lot speed. Yeah.
And there is a legal definition for it within a home zone. I just moved house to a place that's technically a home zone, so the speed limit on my new street is 15 kilometers an hour, 10 miles. So it is possible, but you don't see too many of those. They're more in the real residential neighborhoods, mostly built in the 70s. I don't know what they mean with, the next question is, how do the Dutch deal with their gray roads? I think it is the ones that are in between access and flow. If that's what you mean, I would say make a choice. Go either access or go flow. Don't try and avoid having that ambiguity in the middle.
And that's where I'll add, that's where I really push find out where were those areas where your painted, your striped bike lanes would be appropriate. And there is never a sort of definitive answer as to they are appropriate here. It more is sort of classified in that gray zone of, you know, if we get to redo these roads, we will choose if they should be traffic calmed or sort of more fully separated out.
Yeah, exactly.
So your sort of leftover design roads.
Yeah, leftover streets.
Your leftovers,
Another question about Groningen. I'll pronounce it for you, you don't have to. How did they reduce the amount of traffic volume on the street in Groningen so that the traffic calming was effective?
Yeah. Question. So my understanding was that they had the network density of distributor roads. So with that road being sort of moved towards a more local access road, people could still reach a larger distributor road within 6 minutes. So it wasn't too big of an issue when they changed the design of the street. If those other opportunities weren't there, they would need to sort of rethink traffic circulation. That's my understanding of it. Did you have anything to add to that?
No, it's true. And what we find is that as soon as you lower the speed limit, some of the traffic will evaporate. So you will get 10-20% of the traffic just not appearing anywhere else in the network. We've done several case studies that show this happening. So it is a real thing. Traffic is like water. If you turn up the temperature, it will evaporate. A good question about city staff is concerned with keeping the traffic moving on arterial streets. This leads to challenges. There is resistance to installing flexi-posts. I think the trick there is that it's not about speed, it's about flow. You want to move people moving people is more important than how fast these people are going. So that's where the design concept of driving slower goes quicker. It actually has very high volumes, but at a lower speed, because 50 is not ideal for moving people when you have intersections to deal with. Actually, a lower speed is more efficient of moving more people on a street like that. Now, there's a question about traffic calming for motorcycles, but I don't know what it means. Do you move car parking away from the curb as an inexpensive way to narrow a road, or are there not any wide roads left in the Netherlands? There's definitely wide roads. Actually, we have the widest motorway in Europe, in the Netherlands. We're very proud of that. In the Netherlands, we don't have to move the parking into the road to narrow it anymore, not very often, not in the urban areas. But it is a fantastic way to narrow your street, because if there's one thing people are scared of is damaging their own car, but damaging somebody else's car at the same time, that's terrifying. So people will want to stay away from those cars. So if you do have very wide roads, yes, move them in. Mary, what's your street width in your street? Do you know? Have you measured it yet?
The street width where I live.
Is it wide?
You know, it's on the. It has room for people to park on both sides of the street and two cars to narrowly pass each other.
Oh, that's good.
It is a. We're debating if this is a suburban street or a city neighborhood street. So it's very very residential. Yep. A lot of kids playing in the street. Pretty narrowed, and the parking helps. That's why you moved there, isn't it? Here's a question about, is the raised median proven to be more effective than a painted median? It is. It is more effective, and we're seeing a lot of entities move towards that. I don't have the exact data for you at this very moment, but we can find that out. The Netherlands uses many bricks. You mentioned a fear of mine that it's too expensive to use and lay these materials. Are they really more expensive, or is there some economy of scale there? Great question. Bricks in the longer term are cheaper than asphalt here in some cities. One, because there's a lot of people who can lay them, which helps. Two, if they get damaged, you flip them over and they last for another 30 years. Three, if there's anything broken underneath or you want to do work on the pipes or the sewage system, you just take out the bricks, dig a hole, fix the pipes, and put the same bricks back. So it's quite a durable material that you can use over and over. So the actual life cycle cost is lower for bricks than it is for asphalt. Leonard, can I also add to that? Maybe you can instruct people on what to Google, but it's a little bit of a lighter sort of infrastructure too. There's these trucks that have basically like sheets of pavers or sheets of bricks sort of, and then as they go along, they're sort of unrolling the bricks onto the street.
Yeah, that's true. We're very efficient. Yeah, that's a good question. Very efficient at laying bricks at the moment. Although those paving machines, you don't see them that often. They do good on. They do very well on Twitter, but you don't see them that much in real life.
Okay.
Here's a question about. It's kind of about intersection. It is the last question because it is about. Yeah, we're about 4 minutes away from the end, which is perfect. Last question is, can you touch on signalization as a means for traffic calming on arterials and corridors where other physical design elements are not fitting or possible? That is a great question. Mary, what do you think?
I think, and maybe you had this in one of your other webinars, Leonard, but we would not opt for signalization too often if you're thinking about traffic calming. It's largely because it doesn't contribute as much to safety. So if we're thinking about calming traffic, it's really very closely tied into that safety aspect of it. I'll let you add to it from here.
It depends on what your goal is. Like if your goal is to slow down the cars and there's not actually that many people crossing, it can be quite effective to just make the traffic lights very annoying. But you should be careful about letting a lot of pedestrians or bicycles cross that road at the same time, because it's not going to give them the same level of protection as a roundabout, for example, would be. Because the roundabouts, well, coming back to designing the hardware to fit the use, you physically cannot drive very fast through a well-designed roundabout. But you can travel very fast through a well-designed traffic light because nothing's physically stopping you. So yes, a roundabout would do better. Traffic lights, I've just been driving, moving house, I'm driving quite a lot through Utrecht. And Utrecht has horrific traffic lights, and I think they do it on purpose. So if you have a lot of lights that are red all the time, they do slow you down a lot and just make driving really, really annoying, which can be great, but it might backfire because people will start running the lights and then you get into more trouble when there's pedestrians crossing, for example. So from a safety perspective, try and put in physical elements that slow people down and not rely on signage or traffic lights alone. But it's complicated. So with that, I think we're going to have to wrap it up. There's 15 more questions, but we'll have to save them for the next webinar. These webinars are only the first tip of the iceberg to really get to know our thinking and the way we do things at Mobycon. 2 more things to tell you. The first one is that if you like the way we think and you are running, for example, a complicated project, there's some input that you would like, but you don't know, you want some question answered, we have the Moby Coach program where it's basically just having a Dutch designer on call where you can we can schedule several calls over a period of time where you can just ask us any question that you have about traffic calming or about intersection design or about communication or about education, everything that you are interested in from the Dutch mobility expertise. You can have a Dutch person or a Dutch mobility advisor on call. So send us an email if you're interested in that. It is very affordable for the time being. It might be a little bit too affordable. And then the last slide is to thank you very much. If you enjoyed this webinar and you want to be kept up to date about future webinars, the best way to do that is to register for our newsletter on our website, mobycon.com. Search for newsletter there and you'll be able to find it. And then we'll send you an email so you can be the first to register for the next one, as long as these are free, which may not be forever, just warning you. So thank you very much for coming. Thank you, Mary, for joining us from North Carolina. This was technically quite a challenging webinar, but I think it went well. So thanks for joining us. Thanks, Melissa, for introducing us. And thanks to our technical team for making this all happen. And we'll see you at the next webinar in a few weeks. Subscribe to the newsletter and we'll tell you exactly what it is. Thank you and see you later.